Hello learners, welcome to Learn with artihcpc channel. In this video, we will discuss about AC circuits and transformers subject which is in the C23 regulation of Diploma in Electrical and Electronics Engineering. This subject code is EE303. In this subject, the first unit is the fundamentals of AC. In this topic, first we have to discuss about some introduction part. So in this introduction, we have to know about AC and DC. So AC is nothing but which is the alternating current. Here, an alternating current which reverses its direction of flow at regular intervals is called an alternating current. Here, an alternating current is not constant, it is discontinuous. It flows forward and also backward. And DC current, the current which flows in only one direction irrespective of time is called a direct current DC. So DC is the constant current which flows only in one direction. So in this both AC and DC, we have to observe the AC is mostly used because it has several advantages over DC. So here, these are the two waveforms and diagrams of DC current and AC current. So in this, so suppose this is one wire or conductor. So the direct current which flows only in one direction. So in the AC, it flows back and forth. So it flows forward and also backward. So when we see the graph between current and time in the DC, so the current is constant irrespective of time. In the AC, the current is one complete set of cycles. So it is the number of complete set of cycles which flows forward and backward in the both positive and negative half cycles. So and also one more thing is the cycle. So cycle is the definition. We have to know one complete set of positive and negative magnitudes is called cycle. And also frequency. Frequency is the number of cycles per second is called frequency. In 1 second, how many cycles are produced is called the frequency. Frequency units are hertz. So the normal frequency is 50 hertz. Another important topic is relationship between poles, speed and frequency. Let P equals to number of poles. So suppose we have taken the alternator. So alternator which produces AC power. So in the alternator there are two parts. So one is stator and another one is rotor. So stator is the stationary part, rotor is the rotating part. In this rotating part there are poles. So that poles are pairs of poles. So let P equals to number of poles. Number of pairs of poles equals to P by 2. Number of cycles induced for one rotation. So for one rotation, how many cycles are induced? So for this formula, it is equals to number of pairs of poles. So number of pairs of poles equals to P by 2. So again, number of cycles induced for one rotation equals to P by 2. Let speed of the rotor. So speed of the rotor is the, we know speed symbol is N and its units are RPM, which is revolution per minute. Number of cycles induced in 1 minute. For 1 minute, how many cycles are induced? For this, the formula is it is the product of number of rotations in 1 minute into number of cycles induced in one rotation. So here number of rotations in 1 minute equals to, so this is the rotations in 1 minute. So that is called revolutions per 1 minute. So revolutions per minute is the symbol n. So I will write n here, n into number of cycles in one rotation. So number of cycles induced in one rotation equals to p by 2. So n into p by 2. So this is the np by 2. So we know frequency is the number of cycles per second. So in 1 second how many cycles are produced. So here number of cycles in 1 minute. So 1 minute equals to np by 2. For frequency, number of cycles per second. For this, minute is converted into seconds. So when we convert, so np by 2. When we convert minutes into seconds, we have to divide it by 60. So this is np by 60 into 2 is the 120. So the relationship between poles, speed and frequency. So F equals to NP by 120. From this, so from this speed N equals to, so from this speed N equals to, we have to write 120 F by P, and also P equals to, so 120 F by N. So this is the relationship between frequency, speed and poles.